Okay everyone, welcome back to another episode of CPP4Beginners.com's continuing tutorial series. You're going to notice that this is the first, and it will also be the last time I am going to use a pre-prepared sort of thing that I won't be generating in real time. And I would go on to a big explanation as to why, but I'll put it simply as this. I have tried recording this video about 7 times now. Each time I've taken 15 minutes plus, and it needs to be under 15 minutes for YouTube. So I'm really in a bind, and I am just entirely unable to conform to YouTube's time standards. So I'm going to go through and explain it line by line instead. This should make things easier on you guys as well, because you won't see me making errors along the way. You'll notice that I've taken what we had last video and I've included it already. This is the linear search right here that we had down at the bottom. I've moved it up to the top because I felt I needed to make more clear that you can use a linear search on unsorted data. That's the whole point of it, is if the data is unsorted, you pretty much have to use a linear search, because it's the only type of search that's going to hit every record until the one you want. A binary search, which is what we're going to be talking about in this lesson, is the exact opposite. It's when you take sorted data and then you find the midpoint and you compare the midpoint to what you want, and then you eliminate everything other than the midpoint. You eliminate either everything below it or everything above it. And I'll show you how we do that. This little loop right here. Oh, and actually I didn't finish coding it. We're just going to make a quick little thing here. We'll just say found equals false. And then we're just going to go cout. Sorry about this. The value was not found. I thought I had finished that already. My apologies. So, okay. As you can see, we've declared a Boolean variable, and we've set it equal to false. When we find the correct value, which is right here, we're going to be setting that equal to true. We're also going to be couting the value itself and where we found the value. Now, the way that this is going to actually work is we're going to have the array, and I'm going to make a lot of comments here. The array as it stands now is something like this: 10, 20, 30, 40, 50, 60, 70, 80, 90, right? Because we sorted it right here using our bubble sort. So once we've sorted that, we're going to have the array like this. Now, we can do this with arrays of much larger sizes, huge sizes as a matter of fact. As large as memory will permit, to be completely honest about it. At the moment, I think you could make an array of, I don't know, maybe a couple million places. You couldn't do it of type, well, you could do it with type int, but you would have to set it with a non-int. So we'll get into DMA later. We've actually already talked about it briefly. So what this search is actually going to do is, you can see right here that we're taking the average of two numbers. Apparently my mouse wanted to freeze up there. So that means that max plus min, we're taking max and we're setting it equal to the actual size of the array, which is 9. And min, which is the absolute lowest position in the array, which is 0, because arrays are 0 indexed. So that means that it is going to search between the values of 10 and 90. And it's going to search in the middle. Now, in this case, since we're going to be doing integer division, that should actually equal out to 0 plus 9 divided by 2. Now, since it's an integer, that's going to be 4.5, which actually equals 4. So position 4 in the array is going to be 10, which is 0. 20, which is, actually, you know what, I'm going to do it underneath. 0, 1, 2, 3, 4, 5, 6, 7, 8. So those are your 9 positions right there. Now, what we're going to have here is, Jesus, my mouse is giving me a lot of issues. That should actually be 8. Not that it changes the outcome of this at all. So we're going to have between 0 and 8, which is 9 positions. You're going to take 0 plus 8 divided by 2, which equals 4. As you can tell earlier, I forgot that we were using an array of 9 and not of 10, because that's abnormal for me. So that means that we're going to be looking at the value in position 4. So in this case, we can look and we'll see that position 4 is corresponding to the number 50. So in this case, our first sort of value is going to be right here. Now, that's what we're going to be comparing. So an array of middle is actually going to be an array 4 the first time through this loop. And so then what we're checking is to see if the value in position 4 is less than or greater than value. So let's assume that I entered in that I wanted to find 60 here. Well, 50, which is going to be our first value, is less than 60. So what we're going to do is we're going to take min, and min is presently set to 0. First loop. And we're going to be taking it and we're going to set it equal to middle plus 1. So right now, middle is equal to 4. Plus 1 is equal to 5, which means that the lowest value that we could be searching for is 60. So now we've effectively truncated our loop. So now we're just searching for the values 60 to 90 and nothing 10 to 50. By going through our loop one time, it's going to check to see if it's greater than the value. I can get rid of that comment there. It's going to check to see if it's greater than the value, and it's going to come back false because 50 is still less than our hypothetical value of 60. It's going to check if it's equal. That's going to come back false. And then it's going to hit the end of the loop and come back to the top. So now you have the numbers between 5 and 8. So again, we're going to have 0 way over here, 5, and 8. Now, if we do 5 and 8, that's going to be 5 plus 8 is equal to 13, divided by 2 is equal to 6.5, which is really equal to 6 in our standards. Which means that it's going to go through this loop again, and it's going to see that 6 is going to correspond with 70. So in this case, we're going to check and see, it's not less than, and it's going to then check and see that it's greater than. So it's going to take max, which is presently set equal to 8, and set it to middle minus 1, which is 5. And so then, and I'm just going to say second iteration looking looking for 60. So now, next time it comes through the loop, because clearly it's not less than, it's not equal to, it's going to come back to the top of this loop, and now both max and min are set to 5, which means that the average is going to be 5, position 5 is corresponding to 60, and bam, it's going to output it. And I have plenty of time to show you guys this now that I've run through the theory. So we're going to linear search for 60, and 60 shows that, or the linear search shows that 60 is started in position 7 of the array, which it did. But now it's in position 5. We know that because it's sorted. We can see that right here. It's in position 5. 0, 1, 2, 3, 4, 5. So now we're going to search for 60. And it's going to tell us that it was found at array location 5. Now you can actually add some debugs to this if you want. And these might be useful for you guys visualizing it. So what you can do is you can set this equal and output min now equals, and then we're going to do min, and then do a C out here and do a, and I forgot my \n up there, max now equals, and then we'll do max. And let's just run this through one time so you guys can see it. And we're going to do the linear search again. I could have commented all that out, that would have been better. And we're searching for 60 once again. There's IRC yapping at me. I hope no one needs help. And as you can see, min is set equal to 5. Max is then set equal to 5. And then it's able to find the value on its third iteration through the loop. Now, if we were to take a much larger array and try that same thing with that same debug that I just used, you would be able to see how much quicker it is every single time through the loop. If I were to just see out this, actually, that won't make sense because we're just iterating through a loop normally. You guys know how that works. So, in this case, what I want you guys to do as homework, this isn't going to be a homework I go over in a video because it should be self-explanatory. Make yourselves a nice big array. Make it 1,000 or more in size. You don't have to declare it this way if you don't want. If you want, you can propagate it using a for loop, anything like that. But I want you guys to look at what I've done here in terms of this is called a binary sort, by the way. And I want you guys to look at what I did with a binary sort, and I want you to emulate it. It doesn't have to be exactly the same. You guys can add your fanciful touches to it. But this is the basic stuff you need. And if the value isn't found, then this bool flag is never tripped. So when the loop eventually exits, that's going to become true. So if I just search for a number that's not in our array really quick, we're going to search for 60 and then 55, and it says the value is not found. So that's what happens when max becomes less than min, which is our break condition. Okay, well, I hope you guys have enjoyed this. As you can see, I've been browsing Reddit quite a bit today. I didn't really mean to bring that up, and is apparently looking up some WebMD type stuff from my grandmother's friend. So, I hope you guys have enjoyed. This has been a review of binary searches. If you have any questions at all, please ask. This is one of the harder things that we've covered so far. Next lesson is going to be classes. That is the beginning of objects. Prepare for a wild ride, and then a case study. See you next time.